Hello, Precalculus student. This video is for chapter 3.4, graph of polynomial function. Our goal is to relay the function formula of a polynomial function and the graph. Namely, if someone gives you a polynomial function, you'll be able to sketch the graph without technology. Of course, you can use a graphing calculator to check it, but you should be able to do that. And also, if someone gives you a graph, you would be able to kind of like a possible polynomial function. Okay, so that is the goal. So in order to do that, we need to understand the features of a polynomial functions. Um, of course, the most important point of a polynomial function is the intercepts, the x-intercepts. They are the zeros, right? So we know polynomial function had n behavior that goes up and down in different way, but they go to infinity or negative infinity. In the local, they may wiggle, right? And they would have crossed. Sometimes they cross the x-axis. Sometimes they just turn. So when they cross the x-axis, the y-coordinate is 0, so it becomes a zeros of the polynomials. So by solving zeros, we know the points where it touched the x-axis. So we're going to do 4 examples here to find the zeros of the polynomial function if we have a formula. So at least we know those points that lies on the polynomial. So to solve these polynomial function, all of them are not quadratic. So how do I solve for 0? So the steps are you factor GCF, and then you factor difference of square if it is difference of square. If it is 3 terms, you factor by oh, actually it's not binomial. This is a trinomial. Okay, you factor a trinomial ax squared plus bx plus c by diamond or grouping, and then you also can use substitution to factor a higher exponent of polynomial. And lastly, after you finish factoring, you find the zero by zero product property. So let's do some examples. The first one, I have 2 terms, but they are not difference of 2 square. So I will try to factor GCF first, right? GCF. So this become x cubed because x cubed is the common factor of both terms. And then after you factor x cubed, x fifth, x to the 5 become x squared. And then x cubed become 1. So I factor it this way. So this is the GCF, right? And to find 0, I have to equal 0 to this. Oh, well, but x squared minus 1 can further be factored as x plus 1, x minus 1, right? Oh, x minus 1, x plus 1, x minus 1. So then this is all factor. We find the 0 as x equal to 1. X cubed equal to 0 means x cubed. Oh, no, x cubed equal to 0 means x equal to 0 because cube root of 0 is still 0. Then we say x plus 1 equal to 0, that means x equal to negative 1. X minus 1 equal to 0, that means x is equal to 1. So we have 3, 0. At least in the polynomial graph, we know that it would pass through 0, it would pass through negative 1, it would pass through 1. And we also know the end behavior, right? Because x fifth means it is not this, it's drop to the right, drop to the left, rise to the right. But how do I wiggle between them? Do I just go through like a waveform or whatever? So we'll talk about those later. It has to do with how the terms are factored. So this one, we would have x as a common factor. So factor x out will be x squared plus x minus 20. And we say we are solving for 0, so y equal to 0. Then factor inside this is a quadratic, so we can use diamond. Think of 2 numbers, when they multiply, they are negative 20. When they add, they are 1. So it'll be 4 and 5 with negative 4 and plus 5. So when you add them, they are 1. So it will further factor as x minus 4, x plus 5 equal to 0. And then do 0 product property. X is equal to 0. X is equal to 4. and x is equal to -5. So you can think about if I am to graph this function, at least I have 1 point that I know, the -5 point I know, and then the 4 point that I know. They wiggle among them, but how do they do that? We'll do that later. So 2 more. So these 2 are a little different. Oh, there's a typo here. This would be a 3. Oh, okay. It's 3x to the 3. Yeah. So this is a polynomial that is x to the 4th. So of course we don't know how to factor it. We only know quadratic, right? So and then I cannot factor anything out. There's no GCF. So what do? We can use substitution. We can say u is x squared. And so if I square u one more time, it would be x to the 4th. So you can see that I can replace everything here that is related to x as u squared minus 8u plus 12 when it becomes a quadratic expression that I can factor, that I know how to do. So two numbers, when they multiply, they're 12. When they add, they are -8. That is 2 and 6, or -2 and -6. So you would say 0 equal to u minus 2, u minus 6. But u is actually x squared, so you will say x squared minus 2, x squared minus 6. So this can be further factored down, so we can solve it by zero product property. X squared minus 2 equal to 0, x squared equal to 2, x is equal to plus and minus square root 2. And this is x squared minus 6 equal to 0. Likewise, we say x squared equal to 6, x is equal to plus and minus square root 6. So that's 6, 0. So on the number line, you would expect 2, -6, -2, square root 2, no, not -2, square root 2, square root 6. The graph would pass through this point. Okay. Last one. It is supposed to be, let me rewrite it. It's supposed to be 0 equal to x to the 5 minus 4x to the 4th minus 3x cubed. So this is a very simple factoring question because there is GCF. You will say 0 equal to GCF is x cubed, right? And then you have x squared minus 4x minus 3. And then we will try to factor it. What two numbers, when they multiply, they are -3, and when they add, they are -4. Oh, this is a plus, okay. So plus 4, so it's -3, -1, I guess. So it will be -4 when you add them. So you would factor it as x cubed, x minus 3, x minus 1 equal to 0 to solve for the 0. And so you would say x cubed is equal to 0. If you do cube root on both sides, x is still equal to 0. And this means x equal to 3, and the last one is x equal to 1. So you can tell that this goes through 0. The point also goes through 3, 1, and 3. The only difference is you see this x has actually 3 power. So supposedly you should say, well, this should have been 3 times, or, it's a little different from this where it's the power 1. So we will talk about what are those power of the zeros meant later. So another thing that we notice in a polynomial function is we know polynomial function like usually wiggle like this. So they when they pass through a 0 on the two sides, they change sign, right? From negative to positive or from positive to negative. So when they pass through a 0. So there is a intermediary theorem that say because f of x is continuous, is a polynomial function, that means it's continuous, there's no break. If you have to go from f of a to f of b, which is to a number that you plug in for a and b, and one of them, they are the opposite sign. They are either positive to negative or negative to positive. They must pass through a number c in between a, b. Okay, so let's illustrate this facts. So if you see a function, you evaluate some number. So there's a way to check that, oh, there must be a zero between two numbers is if you discover that they change sign, you know, below that number, below that a number or above a number. So for example, I have f of 1, I have x equal to 1 and 2. I'm not sure if there is a 0 between 1 and 2 because this is not easy to factor, it's not factorable. So for things that is not factorable, you can kind of catch where 0 might be. Of course, you can do a graphing calculator, but you can catch it by actually evaluating x. So for example, I'm going to calculate f of 1. So it'll be 7 times 1 to the 5th minus 9 times 1 to the 4th, which is just 1, minus 1 to 1 square. So it'll be 7 minus 9 minus 1. Obviously, it is a negative number, less than 0. Whereas if I calculate f of 2, that would be 7 times 2 to the power 5 minus 9 times 2 to the power 4 minus 2 squared. So this would be 7 times 32 because 2 to the 5th is 32. 32 times 7 is 224 minus 9 times 16. This is 16, right? So that is 144. And then minus 4 more. So of course we know that this is positive. So they change sign. So we know there must be a C. According to the mean-value theorem, there must be a 0. There must have C between. We actually know where it is. It has to be between 1 and 2 such that f of the C is equal to 0. So between 1 and 2, there would be a 0. So in some case, actually, in some software, they actually use this method to check if there's 0. Okay, so let's go back to the x-intercept. When a polynomial function crosses the x-intercept, there's three ways, or there's roughly these three big ways that they cross. One is when they cross the x-intercept, they cross it in a linear way, like kind of like a straight line, very smooth and a straight line. Then we know that this must be a zeros with a power of 1 in the factor x minus the 0, we call it h. H is a 0. 0 is, we call it equal to h. So the power here is 1. It would the graph will show something like this. If I have x minus h squared in my function, I will see a 0 that's touching it and not passing it. The reason is if you have x is a little greater than h or a little greater than smaller than h, in this case it's 0, then they basically have the same sign. So they bounce off. They have 0 exactly at h, at the zeros, but then they are always positive or always negative. And then if they cross the zeros, kind of like curve, like x cubed, then we know that this is the power is 3. X minus h to the cube, we'll see a graph like this. So that associates zeros with a position in that, and also the behavior of the graph close to the x-intercept, and that helps us to graph the whole thing. So this power that we talked about that associated with a factor or associated with a 0, a factor associated with a 0 is called multiplicity. So we don't call it power anymore, we call it multiplicity. How many times this 0 shows up? And so if the multiplicity is 1, it crosses the x-axis, that particular number at like a line. It would bounce off if the multiplicity is 2 or even. It would be like a curve to cross the x-intercept if the multiplicity is 3 or higher. Okay. So this is how we associate the graph's properties with the function formula. So look at this. So we have a polynomial. We do not know its formula, but we can tell that we can tell the x-intercept, right? So let's list the zero. The x-intercept is also called a zero. So this